Hello viewers, in this session we are going to discuss the solution of this logarithmic equation where we have logarithm of x square minus 1 to the base x plus 4 is equal to logarithm of 5 minus x to the base x plus 4, right? So in order to solve logarithmic equations of this type, let us first consider the equation that is logarithm of say p of x to the base b of x is equal to logarithm of q of x to the base b of x, right? So first consider the general case here. So here we have logarithm of p of x to the base b of x is equal to logarithm of q of x to the base b of x, where px, qx and b of x are some functions of x, right? So this equation is of this form, right? So the requirement to solve this type of logarithmic equation is that first will equate these two functions, that is p of x should be equal to q of x, right? And then we must have p of x greater than 0, that is p of x should be a positive quantity so that the logarithm is defined in the set of real numbers. And similarly for this term, q of x should also be a positive quantity, that is it should be greater than 0. And moreover, we should have here a b of x, it should be greater than 0, and the base b of x should not be equal to 1, right? So these type of logarithmic equations can be solved by taking these conditions together, right? So here the first one is that this p of x should be equal to q of x, then p of x and q of x should be greater than 0, so that the logarithm of the function should be defined in the set of real numbers. And then the base b of x should be greater than 0, and b of x should not be equal to 1, right? So now let us compare these two equations. So now comparing these two equations, we can now write p of x is equal to x square minus 1. Then b of x is given by x plus 4. And here we have q of x that is equal to 5 minus x, right? So now with respect to this logarithmic equation, we can now write the conditions using the expressions for p of x, b of x and q of x. So here we must have p of x is equal to q of x. So we have x square minus 1 is equal to 5 minus x, right? And then we have px greater than 0, so we have x square minus 1 greater than 0. Q of x is greater than 0, so 5 minus x is greater than 0, and b of x, that is x plus 4, should also be greater than 0, and b of x, that is x plus 4, should not be equal to 1, right? So corresponding to this equation, we have now these constraints or the conditions, right? So the idea behind solving these kind of logarithmic equation is to first solve this equation and to get the values of x, right? And then we can verify whether the obtained values of x satisfies these conditions, right? And if any of the values of x obtained from solving this equation it doesn't satisfy any of these conditions, then we can readily discard that value of x as a solution of this equation, right? And if the obtained value of x satisfies all the conditions, then we can accept that value of x as a solution of this equation. So now let us first solve this equation. So here we can now write x square uh, plus x, and taking minus x to this side, then we have minus 1 and minus 5 is equal to 0. So we have x square plus x minus 6 is equal to 0. So from this condition, that is px is equal to q of x, we have now obtained a quadratic equation, and this quadratic equation has two roots, right? So making use of the method of splitting the middle term, we can now write x square, and here we can write 3x minus 2x minus 6 is equal to 0, because 3x minus 2x is x, and if we multiply these two numbers, then we get 3 times minus 2 is minus 6, right? So we can now here factorize it. So we have x plus 3, then we have minus 2, and x plus 3 is equal to 0. Then we have x plus 3 and x minus 2 is equal to 0. So we have now two linear factors. We can also solve this quadratic equation by using the quadratic formula, right? That is using this formula minus b plus minus square root of b square minus 4ac over 2a, by comparing this quadratic equation with the standard quadratic equation ax square plus bx plus c is equal to 0, right? So from here we have x plus 3 is equal to 0, and from here we have x minus 2 is equal to 0. So from here x is minus 3, from here x is equal to 2, right? So from this condition px is equal to q of x, we have two values of x. Say x1 is minus 3 and x2 is equal to 2, right? So now let us consider these two values one by one, and we'll see whether these values verify or satisfy these conditions. So now let us take x1 is equal to minus 3, that is x is equal to minus 3 in this expression, that is the base b of x is equal to x plus 4. So when we take x is equal to minus 3 in this expression, b of x, we have minus 3 plus 4, that is equal to 1. So here we get b of x is equal to 1, but we have here imposed the condition that is b of x should not be equal to 1. But here while putting x is equal to minus 3 in this expression, we are getting b of x is equal to 1, right? And this is against this condition, because we should have b of x should not be equal to 1, but here we are getting b of x is equal to 1. So we have to discard this solution. So x1 is equal to minus 3 or x is equal to minus 3 is not a solution of this logarithmic equation, because this value it doesn't satisfy this condition, that is b of x should not be equal to 1. So x is equal to minus 3 is not a solution of this equation. So now consider the second value, that is x2 is equal to 2 or x is equal to 2. Now let us take x is equal to 2 in these conditions. So in the first condition we have here 2 square minus 1 is greater than 0, and 2 square is 4, 4 minus 1 is 3, and obviously 3 is greater than 0. So this condition is satisfied, and here we have 5 minus x, that is 5 minus 2 is greater than 0. So 5 minus 2 is 3, and 3 is obviously greater than 0, so this condition is also satisfied. And here we have x plus 4, so taking x is equal to 2, we have 2 plus 4 greater than 0, that is 6. 4 plus 2 is 6, 6 is greater than 0, so this condition is also satisfied, because 6 is greater than 0. And here we have x plus 4 is not equal to 1, so when we take x is equal to 2, we have 2 plus 4 is not equal to 1, and 2 plus 4 is 6, and 6 is obviously not equal to 1. So x is equal to 2. It satisfies all the conditions here, so we can take x is equal to 2 as a solution of this logarithmic equation. So we can also verify that x is equal to 2 is a solution of this logarithmic equation by taking x is equal to 2 in this equation, right? So let us substitute x is equal to 2 in the left hand side and in the right hand side. So we have now here in the left hand side a logarithm of 2 plus 4, and then we have here 2 square minus 1, and in the right hand side we have a logarithm of 2 plus 4, and here we have 5 minus 2, taking x is equal to 2 in the left hand side and in the right hand side. So we have now log of here we have 4 minus 1, this is 2 plus 4 is 6, and here we have log of 5 minus 2 is 3. Here we have 2 plus 4 6. So now we have log of 3, 4 minus 1 is 3. Here we have the base 6, and here we have log of 3 to the base 6. So these two sides are equal, right? So here we have seen that when we take x is equal to 2 in the given equation, then both the sides are equal, right? So here x is equal to 2 is the only solution of this logarithmic equation, and we have already discarded x is equal to minus 3 as a solution of this equation. So viewers, this is how we can find out the solution of these kind of logarithmic equations.